Okay, our first laboratory activity with our urinalysis and other body fluids here will be all about our urine sample. For this subject, our laboratory activities will be pertaining only to our urine examination and the seminal fluid examination. Although the topic here for the AUBF include other body fluids, but since normally we don't really receive a specimen with the other body fluids. But some of that other body fluids other than the urine and your seminal fluid, the discussion of that will be incorporated in your lecture na lang. In the actual laboratory activity, even if we have the face-to-face, we're just doing laboratory procedure related to your urine examination and your seminal fluid analysis lang din. Okay, so first we have here for the urine examination would be the macroscopic examination. Okay, the macroscopic examination of the urine is, or other name for that is your physical examination. So urine examination is divided into three areas that include the first observation of the physical characteristics or the macroscopic observation. Another one, we have the chemical examination that would allow us to determine the presence of your different analytes present in your urine sample or being dissolved as part of the sediment found in your urine sample. And the third one would be your microscopic examination that would enable us then to identify the presence of your cellular sediments under the microscope. Again, each of these three phases, the physical, the chemical, and the microscopic examination should eventually be correlated with one another before we can diagnose someone to have an abnormality in the urine sample. You just cannot rely on having a physical examination result without correlating that one with your chemical examination result and even, of course, your microscopic examination. Okay, so usually for the physical examination of our urine sample, we are taking note of the following information. First one, we are taking the color. Another one, we have here your transparency. We have here the odor. Another one, we have your specific gravity. So for today's activity, we'll be discussing, okay, related here with the observation of your color of the urine, transparency of the urine. We have also the odor, and we have also your specific gravity. Okay, before you proceed with the observation of your macroscopic examination of the urine, so we have here the preparation of your urine sample. Okay, so ideally for the routine testing of our urine analysis here, we need to, the recommended na specimen for that would be your first morning urine. So first morning urine is the first voided urine after you arise from sleep as, okay, upon waking up in the morning. So that one is an ideal na urine sample for the routine test because that one is more concentrated. Because of course, concentrated kasi 'di ba natulog tayo, nagising tayo, then what you have here more concentrated. Another sample, random. Pag sinabing random urine, the type of the urine na you are collecting that one any time of the day. So kasi pag random ang specimen natin, it's more of the diluted na urine sample. Paano siya maging diluted? It's because na, di ba, within the day, ginagawa natin ay kumakain tayo, umiinom, and that contribute here with the urine output or urine volume. And therefore, pag inom ka ng inom, tapos ihi ka ng ihi, what you have would be a diluted na urine sample. So, pag diluted ang urine sample natin, that would eventually would underestimate the true concentration of your analytes present in the urine sample. That's why we are requiring the patient to at least submit your first morning urine for the routine urinalysis procedure. Okay, so upon submission of the urine sample, so before you proceed with the observation of the following physical characteristics, then first you need to mix the urine sample. You need to mix that one and allowing those sediment which has settled at the bottom of the tube or settle the bottom of the container na we're able that to mix with the entire urine volume. Kasi pag hindi natin na-mix ang urine volume natin or urine sample natin, what we're going to have here would be kung upper portion lang ang gagamitin mo sa sample, of course, it will not provide so with a true reflection of the quality of the specimen of the patient. That's why you need to well mix that one. And after that one, approximately, okay, transfer here 10 ml of the urine sample with your test tube. Okay, and after that one, first, you need to take note of the color of the urine. Okay, the observation, the color of the urine here is being done. If you are your test tube, you try to look down. Okay, so ganun dyan. Hindi siya at your eye level, but rather you need to look down, okay, with your test tube and observe here for the color of the urine. Each of the laboratory actually would have their own way of reporting the color. So it should be standardized. Okay, some laboratory would have a reporting based on the color na yellow. So, paano yellow na reporting? So, pwede siyang dark yellow, light yellow, or yellow. But always, basta, you need to stick to the way of reporting of your lab. So, some naman, they tend to report their urine color here, straw. Straw here, like, ganun pa rin reporting, like, light straw, straw, dark straw. Or, you can also report other color, like red, bloody red, because may presence ng RBC natin. Pwede siyang blue, green, mga unusual, blue, green, orange. You could also report that one. But if you're taking, for example, yellow, ang straw is more of, siya, orange-brown, something like that. Basta you need to have, homogeneous or standardized way of reporting by sticking to your way of reporting in your laboratory. Another parameter that we are taking into consideration here with your physical examination would be, would be the odor. Ay, nako. Okay, the odor here, routinely, we are not reporting for the odor. So, pag nag-check ka ng urinalysis result form, walang nakalagay kung anong odor ng urine. But then again, taking the odor, noting the odor of the urine provides us with some, information as to what, what condition is related for that. For example, mga inborn error natin, like mga metabolic disorders, may mga characteristic odor kasi sila. Although you are not reporting it as part of your result form, but actually you can you can tell the physician like may mga atypical odor. Okay, normal odor, we have here ammoniac aromatic. Okay, however here, pag sobrang tagal ng urine sample na natin, nagkaroon ng bacterial multiplication that would catabolize your urea in your urine by the action of your enzyme urease coming from your bacteria which multiplied because you're not able to preserve your urine sample. You try to break down the urea, converting it to your carbon dioxide and your ammonia. Okay, then of course you can have other odor like fruity related to your diabetes. You can have your mousy in the condition phenylketonuria. You could also have rancid odor in the case of your thyroxyluria or sweaty feet, mabahong paa in condition isovaleric acidemia. Okay, so we'll be taking up that one sa lecture naman sa ating physical examination. Okay, the next parameter here included in your physical examination will be the transparency. As to the transparency here pertains to how clear, how turbid, how cloudy the urine sample. Okay, anyway, lahat ng ating result with your physical examination is not always conclusive. Mean to say, you still need to correlate the result with the chemical examination or even, of course, the microscopic examination. What do I mean with that? Like, if you receive a specimen na dark yellow would not always be related to urinary tract infection or concentrated na urine sample. It might be related like medications, like food intake ni patient natin. Or for example, red na color ng urine, so it will not always indicate na may RBC or blood ang presence in, in that urine sample. So you still need to check, correlate with the chemical examination and even your microscopic examination. Same through with your transparency. Hindi lahat turbid na specimen would related to your urinary tract infection. So you still need to perform pa din naman ang microscopic examination. Dapat nakakorrelate ito sa microscopic and even your chemical examination. Okay, procedure here for the transparency. So if you have your test tube, your background for that should be newspaper print. Okay, then observation of the transparency is by holding your test tube here at your eye level. Tapos ang background mo dapat ay printed. Like newspaper, ganun basta may mga prints. Okay, we have here the reporting. So, you report clear if the specimen ay walang, of course, it's very transparent. Hazy naman if you're able to see small particulate and the print as your background, mababasa mo. Cloudy, so there will have here many particulate matter and nagiging blurred ng ating background. Then we have also here your turbid specimen, hindi mo na makikita ang print. And milky, so what you have here, clotted, may coagulum, so sobrang ganon. Sobrang turbid, sobrang may maklots na siya, coagulum, so that milky. Okay, another parameter that we tend to measure or determine with our physical examination would be the specific gravity. Specific gravity here simply represent the density. The density would eventually the amount of the solute that being dissolved in the urine sample. Specific gravity is highly dependent on the following. The number of the solute, mean to say, the more solute dissolved in the urine, the higher the specific gravity. Or the size of your molecules, mean to say, the bigger the size, the higher the specific gravity. Okay, we have here different methods for the determination of your specific gravity. So you could have your urinometer, you could have your refractometer, you could have your urine strip. Although routinely we are not using the urinometer or even the refractometer with a specific gravity reading, but we just need to introduce this one in order for you to understand the principle. And but most likely because we are using the reagent strip for the determination of your specific gravity. Okay, the first one, we have your urinometer. Urinometer is just your graduated cylinder na meron siyang float. Wait. Okay, urinometer float. Itong urinometer float. Ang urinometer float natin dito may mga graduation sa kanyang stem. That graduation here represent your specific gravity. Doon tayo mag-read ng specific gravity natin. So procedure for that, you need first to calibrate your instrument. So usually we are using distilled water as our calibrating medium. Okay, so procedure for that, first for your distilled water as your calibration, you need to fill this one 3/4 na volume. Okay, so make sure here na ang volume natin ay enough na hindi sumasayad ang ating urinometer float dito sa bottom nito. Kasi pag sumayad siya, dapat kasi ang reading natin nagpo-float dapat siya, hindi siya sumasayad doon sa baba. Okay, another one ay dapat, okay, ayun. And another one, make sure na hindi din ito sumasayad dito sa side. Okay, then after that one, you try to, okay, to measure the specific gravity reading here by, okay, lower lang natin ang urinometer float, tapos bibitawan, and then rotate mo, pag ganon. I-rotate mo ito, ayan. Tapos bitawan mo, magpo-float na siya, and then try to wait kung kailan siya mag-stop. Okay, ang reading nito ay, okay, pag madami ang solute mo dito, okay, di ba, bumababa ito kasi mabigat, at madami ka na di-displace na urine. So like for example, originally dito ang urine natin, pero pag mabigat ito, madami ang tataas. Okay, so madaming madi-displace na urine volume, and that would represent here your solute. Okay, and then try to read. For the grid tayo, wait lang. Pag ang distilled water ang ating calibrating medium, dapat ang kanyang reading here would be 1.00. Remember, when you are reporting your specific gravity, dapat there are 3 decimal places. 1.00. Usually, ang reading natin is 1.005, 1.00, 1.010. Sa reagent strip natin, 0.5, 0.05, 0.005 ang kanyang interval. Like, ang reading niya, 1.005, 1.010, 1.015, 1.020. Okay, ganun. Okay, remember that before you proceed with your test sample here, dapat ang distilled water reading natin ay 1.00. If not, may defect ang ating urinometer, you should not proceed with your testing process. Then after that one, if you've got already your 1.00, then okay, you try to discard your distilled water and then try to fill with your urine sample. Again, try to fill that one, 3/4 volume. And same procedure pa din, ilo-lower natin. Before kagagamit, make sure na dry ang ating float. Okay, and should not be contaminated here with the previous na solution or even the sample dapat. Okay, so, and then lower mo ulit, then try to read the specific gravity reading. Pag nag-read tayo, you need to read that one in the upper meniscus. Okay, pag ganun siya, di ba, ganyan. Upper meniscus here, dito. Okay, why upper meniscus here? Anong rule natin ulit? Pag clear ang solution, that's, okay, lower meniscus. Kasi nakikita natin ang lower meniscus. Pag hindi clear ang solution natin, so since hindi makita ang lower meniscus, then you read on the upper. So, here you read in the upper meniscus. Okay, then we have here correction. Ito ang medyo may computation tayo for this. First one is you need to correct here for the temperature. Okay, so correction for the temperature, ang rule natin for every 3 degrees Celsius increase or higher temperature of the urine sample compared with your calibrated na temperature ng ating instrument. Saan mo makikita ang calibrated na temperature ng instrument natin? So, kada urinometer may lagay dyan na calibrated na temperature. Okay, so nakamark naman siya ang calibrated na temperature. So, rule natin here for the every 3 degrees Celsius increase of your urine sample compared with the calibrated temperature, you need to add 0.001 with a specific gravity reading. Pero pag 3 degrees Celsius decrease or mababa ang urine sample temperature compared with your calibrated temperature, then you need to minus 0.001. Okay, example, we have the calibrated temperature ng instrument natin 25 degrees. Urine temperature natin 22 degrees, so medyo mababa ang ating urine sample compared with your calibrated temperature of the instrument. Specific gravity reading na nakuha mo nung ginawa mong procedure 1.020. Then you need to compute here for the corrected na specific gravity reading. So, we have here the computation for that. So, 25 degrees here minus 22, that's 3 degrees Celsius. So, since ang temperature ng urine ay mababa, anong rule natin? Pag mababa, ima-minus tayo ng 0.01. So, since nakuha mo ng specific gravity reading is 1.020, so 3 degrees Celsius is so equivalent to your 0.001, ima-minus natin. So, ang actual na specific gravity natin or corrected na specific gravity would be 1.019. Another one, we have this example number 2, we have here calibrated temperature ng instrument na 30 degrees. Ang urine temperature natin 37, so mataas ang urine sample temperature natin compare with your calibrated na temperature. So pag mataas, mag-a-add tayo ng 0.01 with your specific gravity reading. Specific gravity here, reading when you are doing the procedure is 1.015. Okay, so we have that 137 minus 30, that will give you 7 degrees na difference. So hindi ito, di ba, may butal. So, ganun. In every 3 degrees Celsius, okay, equivalent for your 0.001, you just need to add or minus na lang depending on that. Kung mataas, so mag-a-add. Pag mababa, ay magma-minus tayo ng 0.01. Since ang difference ng temperature ng urine sample with your calibrated temperature ng instrument is 7, so ganun, ratio and proportion siya. So 7, multiply mo dito. Okay, divide mo sa 3, that gives you 0.0023. Okay, so ano gagawin natin sa 0.023? Since anong urine sample ulit natin, mataas or mababa sa calibrated temperature? Okay, mataas ang ating urine temperature, then we need to add this one with your specific gravity reading. 1.015, then you add 0.0023, that gives you 1.0173. Since ang ating specific gravity ay 3 decimal places lang, so okay, round off mo ito, so still have 1.07. Okay, that's for the correction for the temperature. Okay, another necessary correction with your urinometer, we have here the presence of your glucose and the protein. Because glucose and proteins are very large molecular weight na mga substances. Therefore, when they are present, then you need to make also correction with your specific gravity reading. So, for every gram of the glucose per DL, you need to minus 0.004 with your specific gravity reading. For the protein, for every gram per DL of the protein, then you need to minus 0.003. We have an example for that. Specific gravity obtained here, 1.030. The glucose present in the urine, 2 grams per DL. The protein is 3 grams per DL. Okay, for correction for the glucose, ulit, for every gram, 1 gram per DL per glucose, then you need to minus 0.004. Since the given is 2 gram per DL, so ganyan ulit, ratio proportion, 2 multiplied by 0.004, that's 0.008, divide by 1, that's 0.008. Ano gagawin natin sa 0.008? Ima-minus natin siya. 1.030 minus 1.008, that gives you 1.022. Now we have here your protein. So, ang protein natin ay 3 gram per DL. Ang rule ulit natin, for every gram per DL of your protein na nakadissolve sa urine sample natin, okay, we need to correct for 0.003. Since ang given is 3 gram per DL, okay, so multiply mo dito, okay, then divide mo sa 1, it gives you 0.001. Ano gagawin sa 0.009? Ang result natin. So, since ito na kanina, ang kinorek natin for the glucose, ima-minus ulit natin ang protein. Ang pinaka-actual na specific gravity reading here, 1.013. So, kung nag-correct ka pa kanina dun sa temperature, ima-minus po pa din ulit. Pa-minus po pa din ulit yun. Okay, another method here you could also use for the specific gravity determination would be your refractometer. Refractometer, ito yung, okay. So, we have here the prism for your refractometer. So, dito tayo, okay, para dito, may viewing area dito where you try to read the result. And meron tayong dito na adjustments, screw, na pwede mo siya ikalikutin para mag-correct ang ating specific gravity reading when you're having your calibration. Okay, procedure, okay, calibrate. So, kung ang distilled water, ang calibrating medium natin, specific gravity should have 1.00. If you're calibrating medium 5% sodium chloride, then dapat ito ang ating specific gravity reading, 1.022 plus or minus 1 plus or minus 0.001. And if you are calibrating medium here is 9% sucrose, then you should have your specific gravity reading 1.034 plus or minus 0.001. Kung hindi ito nakuha mo, adjust mo lang dito ng screw natin para mag-fall siya doon sa ating required or expected na specific gravity. Procedure for that one, so it just requires smaller volume ng urine sample natin or even your calibrating medium. So magde-drop ka lang dito. So 1 drop lang. Then itong cover niya, i-cover mo lang siya. So magsaspread na ang ating sample for that. Then, position this one against the good light source. Titingin ka dito. Then, ito makikita mo sa loob. Meron ka dito mga graduation for the specific gravity reading. Then, specific gravity reading here is the area between your light and the dark area. So, may medyo dark area dito, light dito, kung saan ang boundary ng light saka dark, kung saan siya nag-fall, specific gravity that become your specific gravity reading. Okay, we have here correction. Your refractometer, you don't need to correct for the temperature. Usually kasi, kinakalibrate ito between, okay, usually, ang refractometer is being calibrated at temperature between 18 to 35, 15 to 38, sorry, mali pala. Okay, 15 to 38 degrees Celsius na temperature. White ang kanyang calibration temperature, so most likely nagpo-fall naman dito ang ating urine sample temperature. That's why you don't need to correct for the temperature. But for the glucose and proteins, you still need to correct. Same correction pa din na mga ganyan. Okay, for both the glucose and protein. But for the temperature, hindi na tayo magko-correct. Okay, thank you.